All right. Hi, everyone. My name is Michelle Tanco. I'm a product manager at H2O of all things AI app related. And today we're going to do a live coding session where we're going to walk through how to use the H2O Wave SDK to build your own AI applications. So our plan today is to start with a brief introduction of the H2O Wave SDK. What is it? What can it do? Then I'm going to show you how you can run the SDK on your local machine. This is an open source software, so you can start building your own AI apps today. And then we're going to walk through a code demo of how to build an H2O Wave application. Specifically, we're going to make a fully open source app that uses the H2O3 aggregator function to summarize a large data set. And then we'll use the Wave SDK to build a custom interactive app to visualize the results as either a table or plot, whatever our end user wants. At H2O, we've been focused on our maker culture, makers gonna make, in a couple of key categories. This is everything from feature transformation, where we help users automatically find new features in their data set, and we allow you to build your own custom feature transformation recipes. From AI and machine learning, where you can use state-of-the-art models, either from us or build your own recipes to build models, and machine learning interpretability, where you can make sure you're understanding really what's happening in the model and the end-to-end process is not a black box. What we're going to be focusing on today is somewhat new to H2O, and this is our app developer framework. This is a way to build apps completely in R or Python that can be front ends for rapidly prototyping how your users can interact with AI models. All of these maker pieces fit together in the H2O AI Hybrid Cloud. This is a place where you can rapidly build AI applications and share them with your end users. It's a way to deploy your applications quickly without having to think about the security or sharing or scaling for your data science or developer users. It's handled automatically. It allows your data science users to build machine learning models and deploy them into production, and you can leverage your existing machine learning or AI assets directly in the AI Hybrid Cloud. It's a way to make sure you're focused on being an AI company and get your AI applications in the hands of business users. There's not really a point in building machine learning models if it's not for a specific use case to get value out of it. And in this way, with the H2O Hybrid Cloud, we can get those applications in front of our end users as easily as possible. What we'll be focusing on today is specifically how to build applications. We're going to do a demo on writing an app. I'm going to write an app live with you, and we'll share the source code so you can follow along if you'd like to. The H2O Wave SDK is an open source low-code framework in Python and soon R that allows you to build interactive real-time applications. This can be for live updating of dashboards or end-to-end interactive applications that have buttons, drop-downs, and allow your users to interact with your machine learning models or other data without having to know what code they're using in the background. It allows developers of data science models, so your data science experts, to quickly get into app development without having to know anything like JavaScript, CSS, or HTML. They just have to know Python or R. So let's talk a little bit more about Wave and how it works. The H2O Wave SDK is made up of three main components. The first is the application code, and that's what we're going to be writing together today. This is written in Python or R. Today we'll be using Python, and it is the H2O Wave package. You can get this package from Conda or PyPy, and it will soon be on CRAN as well. Your application code sends data, content, or cards, which will show information to the end users, to the content server. And it determines if a user clicks a button or comes to your app, what's going to happen. So all the logic of your application is done in the application code, which you would write. The content server is a small static binary executable that can run anywhere from your local machine to the cloud to a Raspberry Pi. It stores the site content, the cards and pages that your application code builds, and it can transmit any content changes to browsers, so you can have apps that are updated in real time with the latest information. It also takes any browser-based events from your end users and send those to the application code, which would then handle those events and create new content to show to the browser. So everything between the application and the browser is done through the server. The end user, when they're writing code, doesn't really have to think about the server at all. We'll see that today when we're building it. It's completely handled by Wave. It just needs to be running. And then the third component is going to be our browser-based client. This is how your end user is going to be interacting with your content. They can use any browser they want to, Safari, Chrome, or Firefox, and it's a place where you're hosting the content from the content server. We'll look at today some examples of how we actually do that. All right, so we talked about the three components, but how does it work from an app developer perspective? The H2O Wave server holds a collection of pages. These pages run at some browser-based URL, and you can have different URLs on the same server that go to different pages. Each page can hold one or more cards, and the cards can have lots of different types of content. Just 1 second. All right, everyone, we're having a good work from home pandemic moment with my dog. So just a second, thank you. We will jump back into it now. So each page can have one or more cards, and the cards have different types of content on them. On the right-hand side here, we have an example page that has 5 cards. On the top, we have a header card that says what our app does. There's a sidebar on the left, and we have 3 different types of content cards, which are holding different plots, charts, or other information. As a developer, what we're going to do in our application code is reference a page or card, make some sort of change to it, and then save it, and it will be automatically displayed to our end users. This is both for static dashboards or for interactive apps, which have buttons, drop-downs, etc. Any browsers that are pointing to where the app is running will get updates automatically in real time. All right, so we're almost to our live coding section. This is what we're going to build today. We're going to make an application for visualizing any large data set without losing the shape of the data or any outliers. This allows your business users to easily digest and find interesting points in the data set. We're going to do this using H2O3's aggregator function, which will reduce the size of our data without losing information. So essentially, it will find exemplar data rows in our data set and count how many rows of the original data fit in that exemplar. So some exemplars will have hundreds of thousands of rows and others will just have 1 or 2. So this can run on really big data, hundreds of millions of rows. This way our end user can visualize this data because plotting hundreds of millions of rows doesn't work very well. We're going to build a front end that will display the data. The user can choose if they want to display it as a table or as a plot. You might want to as a table because you can search and filter and sort the data, or we can have a plot, which will be a scatter plot of 2 values. So you can see it in aggregate, how the relationships in your data set. The user will get to pick how they want to view the data. So there's a link here to the completed application that will be similar to what we write today. When you live code, it might be a little bit different. This will be put in the chat for wherever you're watching this, either in the future as recording or live, so that you can follow along yourself if you'd like to. All right, so what we're going to do first is I'm going to show you how we would set up for a local dev environment. The only thing we need to do to develop locally is have the Wave server running on our workstation. You can download the latest Wave server by going to GitHub H2AI Wave/releases. The latest version is 0.17, and we do want to download the Wave executable for your operating system, not WaveDB, which is going to be a database that can come with Wave. So we're specifically looking for Wave. So I'm going to show you how to do this in just a minute, but we're going to download the file, we're going to untar it, and then we're going to actually just run the server. So I went ahead and I have this, need a new window. I have my Wave server already downloaded on my computer. So I'm going to navigate to where I have it running, which is in my H2O Wave folder. It will be in the Wave folder. And then when you download and untar this file, inside this is what you'll see. So we have some data that the Wave server might use. We have a demo and example, which are some sample applications, dashboards, and Wave code if you want some more help getting started. And then WaveD is actually the server that we're going to run. So to run it, we're just going to do ./waved. And now we have our Wave server running on our machine. I can see here that it's listening at port 10101, and it's on just my local host. So I'm going to open my browser again, and I'm going to go on my computer to localhost 10101. And here I can see my Wave server running. There's no content here because we haven't put anything in the server, but it is successfully running our machine. I can turn off the server, and then when I come back here, we can see that it is just an empty browser, nothing's running here. But we'll run it again. All right. So we have set up our Wave server on our local machine, and there are more detailed instructions in the documentation, which I will reference at the end of the slide in case you want more details. We're going to set up our project next. So you can write Wave code just about anywhere that you can write text. I would recommend using an IDE. I'm going to be using PyCharm today. VS Code is also quite popular. You can write code in VI or any notebook that you'd like to, but an IDE is going to be easier for debugging our application. We're going to create a virtual environment for our app. For anyone that's not familiar with Python virtual environments, essentially this is going to be a way that we can use very specific versions of Python and packages without getting in the way of any other projects on our machine. So we might have one project or app that needs a specific version of, say, pandas, and another that needs a different version. Using virtual environments, we make sure our projects aren't getting stepping on each other's toes. We're going to create a requirements.txt file for our project so that if someone else were to take our code and use it, they'd know exactly what versions of packages to use. And then we're going to create one source code file called app.py, where we're going to actually put all of the source code for our app. This file name could be whatever you want it to be, but we'll use app.py as just a standard. There are other projects and other best practices that we might want to add to our project. For example, if we're doing a really quick prototype, we might just have source code. But if we're building an application that users are going to be using, we probably are going to want to have unit tests, documentation, maybe some screenshots. We're absolutely going to want to README so new developers know how to get set up. So there could be a lot more in our project, but we're going to be sort of simple today just to get some prototypes going quickly. So I will go ahead and set that up on my machine. We can not close that. We'll make sure this is still running. I'm going to go to PyCharm and open a new project. And one of the things I like about PyCharm is I can have it create a virtual environment for me automatically. So we'll call this code along or live demo. I'm going to use Python 3.6. You can use any version of Python that's 3.6 or later. And then we will go ahead and I already have a project called that. Demo wave building. There we go. And it will create for me a new project where I can start writing some code. So we'll give it just a minute to create our virtual environment. And then what we're going to do is, actually, I will tell you what we're going to do next. All right, so this is how we're going to build our code. So before I create my app.py file and get going, let's just walk through the steps. First, we're going to build not an interactive application, but we're going to build just a static Wave script and set up the landing page for our user interface. This will be when users come to the app, what are they going to see? Once we have sort of that initial UI planned out, we're going to reformat this as an interactive Wave application so that new users see our landing page and users can click buttons or tabs and so forth. We're then going to add navigation functionality. So we want to have two views for our user, a table view and a plot view. So we're going to actually create that navigation and have it so users can click on one or the other and change the view. We're then going to use a mocked up data set just for some quick practice to actually create the table and the interactive plots. And then we'll actually add in the backend, which is the H2O aggregator that we'll use for actually processing our large data sets. So normally, if you were building this UI, probably we would have the backend code done first. We would be building the UI for an existing model or for some existing workflow. But today, since we're focusing on the Wave SDK and how to build UIs, we're going to build the UI first and then the backend second, depending on time. But this full end-to-end app is in GitHub, and that link should be in your chat. Okay, let's go ahead and get started. So I have my folder here with my virtual environment, and I'm going to create two new files. One is going to be a requirements.txt, and one is going to be my actual Python application code. And right now in the requirements, the only thing that we're going to need is the H2O Wave package, and I'm going to use the latest version, which is 17. We are going to also use pandas today, but we'll go ahead and add that to requirements when we get to it. I'll now install the packages, and my IDE will do that for me in the background. All right, in our app code, we're going to, oh my goodness, talking and typing at the same time. From our H2O Wave package, we're going to import site and UI, and we'll give our IDE will need just a minute probably to index and realize that we have actually installed this package. So site is going to be a direct connection to the Wave server, and UI is going to be several different UI components and cards that we're going to actually use on our screen. So I'm going to make a reference. So if you remember the 3 steps to update a Wave app, you reference a page, you change content, and you save the page. So I'm going to make a page, and it's going to be on the direct homepage at localhost 10101. If I wanted to do a subpage, I could do something like this and say /demo. And then when we actually went to our app, here we would say /demo instead. But we're going to stay on root just to keep it easy. All right, what do I want to do with my page? I'm going to make a new card that I'm going to name header. I can name it whatever I want, but we'll name it header today. And the specific type of card it will be is a header card. So I don't have to know HTML, JavaScript, CSS. I just have access to components that have been pre-built. The first thing, there's 3 things I need for a header card. One is going to be the box, which we'll talk about in a little more detail, but essentially it's exactly where on my screen I want the header card to be. So I'm going to say 1, because I want it to be in the top left-hand corner. And then I'm going to say 11, because I want it to be 11 units wide and 1 unit tall. I then need a title. We'll call this aggregated visualizer. And I need a subtitle. We'll call this there we go, say what our app does. Okay, so we've done step 1, we referenced a specific page, the root page. Step 2, we've put some content on the page. And then step 3, we have to actually save it. So I'm going to right click and run this. It ran successfully. Now let's go to localhost, and we did not have a cursive alive demo. It worked. That's good. Here we have our header card. So it's on the top left-hand corner. It's 11 units wide, and it has the information that we put there. So there's a couple other things we're going to add to our base UI. We're going to add the tabs so users can pick what type of view they want. And then we're going to make placeholder content for either the table content or the plot content. So I will go ahead and add a new page here, and I'm going to call it navigation. And it's going to be a tab card. The Wave documentation is at wave.h2o.ai, and you can see all the UI components there, the different types of cards, and see a lot of example code. Okay, so we need a box. So where do I want this? So we're still using the grid-based system right now. I'm going to switch to a layout-based system soon that will be a little easier to think about, do less math. But for right now, I know I want it to start all the way to the left. I want it to be right under my header. And then it can probably still be 11 units wide and only 1 tall. And then what else does a tab card need? This is where the IDE comes really nicely in play. We can see it needs items, a list of tabs. So we'll say items. We're going to have 2 tabs. One is going to be for our table view and one for our plot view. So the name is going to be the way that the backend site content knows what this item is. So it's going to be sort of a computer-friendly name. I'm going to do all lowercase. And then the label is what your end user actually sees. So it's something a little more pretty. I'll go ahead and just copy this and then do the same thing for plot. All right. and then we'll save, we'll run it, and go check it out. And here we have our items. Now, at this point, this isn't interactive yet. If I were to click this, nothing happens. It doesn't know, my site content doesn't know what to do when I click this button. So that's what we're going to program in soon. All right, but let's go back here. Instead of doing a grid based, I'm going to actually create a layout system to use so that the different cards can be placed on the screen in relation to each other rather than in exact locations. And I'm going to do this one because it's easier for me to think about, but also what if I have someone that wants to view their aggregated data on mobile or on an iPad? Using the exact grid layout, it's not going to work so well. So we're going to switch to a layout. So I'm going to use a meta card for this. And the UI meta card has a lot of different types of options. This includes being able to change the information that's here in this tab text. I could change this favicon. There's a lot of information in the meta card, but we're going to just look at the layout for right now. So we could add multiple layouts, like if we wanted the content to be one way for mobile and a different way for desktop, but I'm going to make just one layout today. The breakpoint I'm going to call extra small because I'm going to make a layout that would be okay on mobile, even though we're doing desktop development. And then the only thing I need is a series of zones, and these are all going to be relative to each other. So by default, the zones are going to stack on top of each other, but if I wanted any of the zones to stack horizontally instead, I would just tell them that. But I'm going to have 3 zones. I'm going to have zones. I'm going to have a zone called header that will be on the top, a zone called navigation, and then a zone called content. Oops. And just to be content, there we go. Just to be super clear, it is a coincidence that the page name and the zone name are the same, just because that's the type of information there. They do not have to be the same. What I'm going to do is come here into the box, and I'm going to change this to header, and I'm going to change this to navigation. And then we're going to save it and run it. And we're not going to, in this case, really see a difference right now. But if we were to add anything else, they would all be relative to each other. And if I were to look at this on a, if I were to, like, say, make my screen smaller, it's going to automatically adjust rather than scrolling over, like if I had it 11 units wide. Okay. Oh no, I lost, there, it's my browser. So let's get back into it. We now have the start base UI of our application. We still need to decide what happens when someone wants the table view, what happens when someone wants the plot view, but I'm going to switch now to an interactive application. So I'm going to add 3 more imports here. Q, which is the query object, or how we're going to interact live with our server. App, which is we'll talk about app in a minute, and main, which is how Python knows that this is basically has a main function in it. I'm going to, instead of using site, we don't need site anymore, I'm going to use app. And what app does up here is it says whatever function comes next is going to be the interactive function. So if I have a new user, if someone clicks a button, anything like that, they're going to get sent to whatever function has app above it. So just like with site here, I could change the URL. I could have multiple apps running on the same server, but we're going to do the base URL just for ease. All right, so let's put all of this into our serve function. Okay, but we're getting told the page doesn't exist, and that's because page is now inside our query object. So instead of site is for static apps, and Q is going to be for interactive apps. So I'm just going to change this to Q.page for all of these. And then for anyone who's maybe new to application development, I just want to call out this async really quick. Essentially, we're building an asynchronous application so we could have multiple users all hitting the app at the same time and they wouldn't have to wait for each other on the back end. So you're going to see async and also await throughout this application, and essentially just know that it is a way to have multi-users asynchronously interacting with our application. You can look into more, but that's basically what's happening here. Okay, so we now have this new setup, and we're going to run the app a little bit differently. Instead of right-clicking and running this like a script, we're going to actually use our terminal. You can set it up in VS Code or PyCharm up here using the run button, but I'm going to run in the terminal. And I'm going to say wave, which is in my virtual environment. I'm going to say wave run app, and it's going to run this as an application. Now I'm going to come here. I see the same thing, so maybe we're not sure if anything's changed, but let me show you what's cool about apps running is I can change the content, hit save, do nothing else. It will automatically reload the app for me, and I see my changes in real time. So especially if you have two browsers, two monitors, this is really nice because you can write code down here, and on your second monitor, you can just see it updating in real time to see how it's working for you. So we now have the base for an interactive application. So let's we're going to come up back here. If you remember earlier when we had a static wave script, when we clicked on plot, it waited forever. So now let's see what happens. When we click on plot, it's flashing and going back to table. So the reason for that is because, let's print our arguments from queue. Every time that I click here, it's calling that serve function again. So we can see that it's saying they're clicking on the plot, but I haven't set up any logic for what happens when I click on plot. I am just rewriting the whole UI. And so this is where we will start setting up our app logic. I'm going to make a new function that's going to be called set. We're going to be really descriptive for our live demo today. Set up UI for new user. And it needs queue. And we only want to run this for people who haven't been at my app yet. So what we're going to do is use our query object to track information about different browsers coming to the app. So we're going to say if not queue.client.initialized. Now, initialize is a variable inside of my client state that I'm making up right now. What I'm going to do inside of my setup for new user function is I'm going to make this equal to true. So once someone sees the UI once, I don't need to show them the base UI over and over again, only one time. But I want this to happen for every user. So if a new browser tab comes to my app, I want them to be able to see it. So we're going to run this code for every new user. All right, so I'm going to save this and we'll come back here. And when I click plot view, it's loading again because I haven't set up the app logic, but I've told it don't repaint my whole UI. So we're making progress. All right. So I'm going to make two new functions down here called table view and plot view. And right now they're just going to be placeholders. So I'm going to say queue.page table view equals UI, and we're going to use a form card. Form cards are a good catch-all. They are good for actual forms if you want someone's like username and password and buttons, or if you want to have a lot of information in a row. So we're going to have a form card. The box is going to be content. And we're going to have a list of items. The only item I'm going to have right now is a large text heading that says table view. So it's not too exciting. But I'm going to do the same thing for plot view. All right, so we have these two functions. So now we need to tell our app when to show them. So I saw down here in my, oh, refresh for me, thank you. I saw down here in my query object that every time I was clicking the plot tab, it says plot is true. And that's because that's the name of this tab. So if I were to change this to something else, it would say that was true. So what I'm going to do up here is say, if not initialized, show them the new screen. Else if the argument called plot is true, I want, let's do table first. If the argument called table is true, I want to do the table view. And if the argument called plot is true, I want you to do, what did I call that? Yeah, plot. Oh, plot view. Oops, that's not what we want. Plot view, much better. And we need to give it the query object. All right, so let's save this. So we've started to put in some of our app logic. So let's go check out how it works. When I click on plot view, I see plot view. And when I click on table view, I see both of them, but I do see table view. So we have made it so that when we click these buttons, we see the cards we want. All right, so what we need to do next is make a little change to these. When I go to the table view, I'm going to actually delete my plot view card. And if it doesn't exist, nothing will happen. That's totally fine. And when I go to the plot view, I'm going to delete the table view card. So if you go to the GitHub and you look at the live code, we do this a little more cleverly. We're going to have a function that will delete all the cards for us. But for right now, this is a quick way to just, since we only have two main views that we're showing, delete one or the other as we go there. So now when I click plot view, I see the plot view. When I click table view, I see the table view. All right, there's one more thing that we want to do. If you notice when we're actually at our app, we don't see our table view. So I'm going to go back up to my app logic and say, if you're not initialized, if you're new here, I'm going to set up your UI, and then I'm going to show you the table view as a default. All right, and now we have that there. So we can see it's pretty straightforward to start adding in our content for our UI. And at this point, we're going to actually create our fake data set, and then we'll create the actual table view and plot view for those pieces. All right, so I'm going to make a function called aggregated data. And eventually, this function is going to use, it's going to start an H2O cluster. It would allow you to say, upload a data set. Maybe you want your user to bring in data from S3 or from some database. We'll put the data in the cluster, and it's going to do the aggregation function. But right now, we're just going to use a really simple data frame that has less than 100 rows to do practice for our UI, rather than running the aggregator function every time while we're still doing our initial testing. So I'm going to go ahead and import pandas, which is not in my virtual environment. So we'll go to our requirements, we'll add it. And any version of pandas is fine. I'm going to just use the latest, and we'll install our packages. And then we'll wait for our index to be reset so that it knows that this is installed. All right, so for right now, I'm just going to make a really simple data frame that has 3 columns. It's going to have C1, column 1, which is going to be 100 numbers from 0 to 99. I will have C2, which is going to be more of the same. And then I'm going to have counts. And the reason I have counts is because when we actually run our aggregator function, it's going to take our millions of rows and reduce it down to close to 100 rows. And each of those will have some sort of count. So that's where we're going to just simulate that here with some fake data. And we'll say return df. And then let's go ahead and do some little logging for ourselves. We're going to print the first 5 rows of this when we call this function. So I'm gonna just add that. We'll call it here because we'll do our aggregated first. So if I go ahead and I need to run my app again, it's going a little slow, isn't it? There it goes. So I, down here when I called this function, I had it print and you can see our fake data here. So we'll replace this again with real aggregated data, but we're just doing some testing for now. Okay, so let's make our table view first. So there are 100 plus different types of components and cards available in Wave, and one of them is a table. So I'm going to make a table, and there's going to be three parameters that we need. We want a name for the table, so I'm going to call this aggregated data table. It needs some columns, and it needs some rows. All right, so I have my data frame here. So the columns are actually going to be UI dot table column objects. And this is because we can give them all sorts of different properties. Like each column could be sortable, filterable, searchable, and so forth. So we could be very customized and make the exact column we want for each of our inputs, but I'm going to just make all the columns the same using Python's list functionality for now. So I'm going to say that the name is going to be the column name, the label is going to be the column name, and this call doesn't exist yet. It's going to be for call in df.columns.values. All right. And then, oh, I guess I don't need these parentheses. I'll get rid of them so it doesn't yell at me with its squiggles. All right. So now if I go ahead and save this, I look here and I can see my three columns and from my data set. But we haven't added any rows yet. So in case anyone is not familiar with sort of creating lists in Python, that's what we're doing here. We're taking the list of column values and we're making a list of these UI table column objects. So now we're going to do that for our rows as well. I'm gonna look over here. Here we go. Okay, so I'm gonna do the spacing on this a little different. So we're gonna use the table row item, and it has two values. It has a name and it has the cells, which is a list. Okay, and we want to make a table row for every row in our data set. So for each row in the length of our data frame, because this could be variable length, it might not be 100 rows when we do our aggregator function, I'm going to make a table row. So this is creating a list of, at this point, 100 table rows. The name of it is going to just be I. And this is so that if a user selects a row, we know in our serve function what rows they selected. And then we actually want to get all the data from that actual row in pandas. So we're going to say that we want a string data type. We're going to do the column, the data frame dot column values I, and this is going to be for column in df.calls.values. Awesome. So there's a lot of example Wave code. We have a repository called wave-apps that's open source on GitHub, and it has things like this that you can copy and paste from. So essentially, this is going to take every row in my data set and put it in my table. So now I have my 100 data points. There's a couple of things we might want to add to our table. For example, our users might want to download the aggregated data. So in addition to name, columns, and rows, I can say downloadable equals true. And then I have a new download data button here. When I click it, you're going to watch it go, and now I have it available. So I could go do whatever I wanted with this data. We could make these columns searchable, filterable, and so forth. But at this point, we're going to stop with our table view, and we're going to actually set up our plot view. All right, so I know that I will need this data frame in my plot view. So I'm going to bring it over here. And now I'm going to show you the power of looking up code that already exists. So we're going to go to the documentation, wave.h2ai, And I'm searching specifically for pandas. I'm going to look at the example of how to plot from pandas and just copy and paste this rather than having it memorized. So essentially, when you're building a plot in Wave, you need to tell it what data you want to use. And there is a new import we need called data. But this data import is basically a data buffer that would allow us to add new data in real time in a really memory efficient way. So I need for my plot, I need the data from my data frame and then my actual plot object. So I'm going to just copy this and we'll talk through it. Here we go. So we have plot view. Oops, I forgot the UI visualizer option. So I'm going to actually make a visualization, but it needs the data for the visualization and the plot. Okay, so our data is going to be taking the fields as all the columns in my data set. The rows is all the values in my data set. And then path equals true means in this case, the data is not going to change. We're not going to be doing real-time live updates. So this one's just going to make it more memory efficient. If I wanted to have a dashboard that updated automatically every minute, hour, week, and the data was going to be changing, I'd be pushing in new data, I would not use pack, and it basically makes it mutable. All right. And then we're going to look at the plot variable. So in a UI.plot, you can have multiple marks. So you might want to have a line with points on it. You might have intervals that are annotated. So in our case, we're going to have just one mark, and it's going to be a scatter plot. So the type is already correct. We're going to do a scatter plot. There are lots of different available options. You can do your bar plots, histograms, lines, and so forth, but we're going to do scatter plot. In X and Y, it's looking for the column names from our data that we want to use. So I'm going to start by visualizing C1, column 1, by column 2. I don't want to give them special axes titles yet because this is sort of variable. We will end up writing this code so that it could work on any data set, but right now it's going to only work when we have columns called C1 and C2. I don't need a special color for the specific plot, but I am going to add in the size. And we're going to say I want the size to be equal to whatever data in here is called counts. So each point is going to be a different size based on the counts. So I'm going to hit save. We'll come back to our app, click on the plot view, and here we have our scatter plot. So once you are starting to get started building plots in Wave, it's pretty straightforward to do. If we wanted, we could change the color of these points. We could change the axes title and make the plot look a little bit more like our brand or visually interesting to our users. But at this point, we have a table view and a plot view. So what we're going to do next is add a drop down to this plot view that lets the users actually choose the X and Y columns, because our large million row data set might have hundreds of columns and we want the users to be able to explore the data. That's the point, is to let people understand their big data. So let's go back to our plot view, and between my title and my visualization, I'm going to add a drop down list. All right, the name of the drop-down list is going to be X variable. And then my drop-down list needs, we'll give it a label so that users know what it is. We want to make this as easy as possible for end users. X variable. And let's see, we also want to have choices. So this is what the user can actually choose from. So choices is going to be a new UI object called UI.choice, and it needs a name and a label. So the name is going to be equal to call. The label will be equal to call. And we're going to do this for column in df.columns.values. There we go. And let's save this. So now when we go to our plot view, we have a big X variable that has all of our columns available. It doesn't do anything yet. When we click on it, nothing's going to happen, but we've really quickly added in a new component. Okay, So I want my X variable and my Y variable to be right next to each other rather than one on top of each other. So I'm going to use a new UI element called inline, which has just one, we'll actually use the parameter so you can see what I'm doing. It has one parameter called items, and I'm going to actually put my drop-down list in it. So inline is going to put different types of components next to each other. Okay, so in a new component called X variable, and it will also have all the columns. So now when I go to my plot view, I have my X variable and my Y variable as two drop-downs next to each other. So we're able to easily add in these components. Okay, so now let's add the logic to them. When I select a X variable, I want my X-axis to be updated with this data. So what I'm gonna do, my name is X variable, and I'm gonna add a new parameter called trigger equals true. So when someone changes this, I want the app to send that value to the serve function. So now when I select a variable here, it's going to say loading because I have not implemented this functionality, but it's paying attention to the changes for me. All right, I'm going to copy the name of this dropdown and go back up to my serve function, and we'll go through the logic again. If you're a new user, I want to set up the UI for you. If you've clicked the table view, I want to show you the table view. If you've clicked the plot view, I want to show you the plot view. If the X variable has been selected, or is it or? There we go. We're gonna wait, sorry. If QArgs, the X variable is not none, or if QArgs.Y variable is not none. Oops, is it or? There we go. And we're gonna just do parentheses to be clean. And we'll test our work before we code the functionality. Plot variables change. I'm going to change one of my variables, and I'm going to look here, and it printed. So we were able to catch that here. Okay, so when the plot variables change, what I want to do is I want to change this to whatever is appropriate, and then replot this. So what we're going to do is create in our user setup, we're going to create a new client, X variable, and Y variable. And just for now, we're going to start by hard coding it with C1 and C2, just so that we don't do 10 steps all at the same time. So we're going to start by the X variable is going to be C1 and the Y variable is going to be C2. Okay, the reason we're going to do this is so that up here, when someone selects one of them, what we'll do is change it. So we will reset this X variable as the argument that was selected. We'll reset this Y variable as the argument that was selected, and then we'll recall the plot view function. Now I'm going to copy this again, and I'm going to update my plot view, and I'm going to say that this is not C1, it's whatever values inside a client variable. And this is not C2, it's whatever variables inside of Y variable. Okay, we could also, let's change our title and let's make it say relationship between these two variables. We'll go ahead and save it. And we'll go to our plot view. And now I'm going to change this to C1. Oops, live demo. Okay, that didn't quite, oh, I know why that didn't work. Okay, that didn't work because we changed C1 and you see the value here is empty. So it set the value of X to empty. So what we're gonna do is come to our drop downs and I'm gonna say that the value of this drop down is equal to whatever is in my QClientX variable. And the value of this drop down is gonna be whatever is in my Y variable. Back to the plot view, and let's try plotting C2 by C2. And there we have it. We can try doing counts by counts or counts by C2, counts by counts. All right, so I'm gonna say this is a good stopping point for us. We didn't get to adding in the H2O aggregator function. We're just using fake data right now, but this is available in the open source repository if you wanna see how to use that. In there, we're gonna create a 1,000,000 row data set, aggregate it down, and then let our users visualize it. So I'm gonna jump back into the slides and tell you what you can do next if you wanna learn more. No, I do not wanna share this with anyone. I wanna present. There we go. All right, so what we could do if we wanted to keep going with this app, please feel free to fork the repository and make some changes. We can let the user actually upload a data set. So in the final code in the repository, you'll see we create a fake data set in H2O3 that's 1,000,000 records, but you might want to add the ability for your users to upload their data from their local machine or talk to a database. Anything you can do in Python or R, you can add to your app. For modeling or data reducing, in the sample code, we're just spinning up an H2O3 cluster on our local machine, but you might want to connect to a production cluster that's running in Hadoop or somewhere else. We could also let the end user make some parameter decisions about the aggregation. So in the final version, we are deciding for them how the aggregation should be done, but maybe you have a more technical end user that wants to decide if they're aggregating down to 100 rows or 1,000 rows. So that's something you could add in. For right now, for the visualizations, we're just doing a scatter plot of every 2 columns, but it might make more sense to do lines or intervals or plots depending on what types of data you're looking at. So you could add more logic into the visualizations to show different visualizations to your users. And then there's some app robustness we could do. We absolutely need a README for new developers, and that's in the GitHub for you, but we might want to add unit tests or documentation as well. One thing I wanted to mention, so we are looking at building applications on your local machine today, but the H2O Hybrid Cloud allows you to deploy applications so end users can have access to them, and that you as a developer don't have to think about scaling or security or any of that. So if you would like a trial of the H2O Hybrid Cloud, it's really easy to sign up. You go to h2oai/free and you can get a 14-day trial. Just be sure to use your corporate domain or corporate email and check your spam folder because sometimes those types of things get stuck. You'll be looking for an email from Cloud, no reply, but this gives you access to the whole H2O Hybrid Cloud. You can see over 35 applications built by the H2O team. Some of them are example applications and others are going to be end-to-end solutions you can use today. You also have access to our AI engines, including H2O3 and driverless AI, as well as MLOps for deploying. So go ahead and make an account if you want to give that a look. A couple resources I want to point you to. So we'll be putting these slides, I'll be linking the slides to the GitHub, we'll host them publicly somewhere, but you might want to check out the Wave documentation, that's wave.h2o.ai, where you can see, there's 2 main ways to get started there. One is for my hands-on people, there's hands-on tutorials, sort of like what we did today that walk you through how to build applications. And then if you're more of a learn by reading, there's a deep dive into the various concepts. So we talked about some of those concepts today really fast, but you can get more knowledge here from the documentation. There's a link to a public repository called H2O/Wave-apps, and that has 7 open source, fully end-to-end application codes, some of them with unit testing and so forth. So you can see how all of that works. And they solve some common business use cases on public Kaggle data. We also, from the H2O training team, have tons of trainings and tutorials. You can see a list of some of them here, which gets you started with building machine learning models, understanding how to do machine learning interpretability, and building models for different types of use cases like time series or NLP. And the last thing I wanted to share with you is you can join our public Slack community. Sign up at h2oai/ Slack-community. And you can join us right on Slack, where our engineers, developers, and people like myself will be on to answer your questions. You can also get direct access to the H2O community, which is a lot of clever people using our products for a lot of really interesting things. So at that point, I will wrap up. And if you have any questions, please feel free to put them in the chat, or you can join the community and ask them there.